Hi guys. Okay, so in this video, we are going to cover the problems 27, 29, 33, 35, and 39 from chapter 4. Okay, so these problems relate to the the number of protons, the number of neutrons, and the number of electrons, the mass number and the atomic numbers and the symbols, and finding the atomic mass or the isotopic mass using the average calculation method. So these problems, so as you can see that every element has a name, every element has a symbol. There is an atomic number associated with every element. That atomic number defines the physical and the chemical properties or the nature of the atom. Okay, the identity of the atom is associated with the atomic number. So for hydrogen, the atomic number is 1, and that 1 is only going to belong to hydrogen and nothing else. Nitrogen, the atomic number is 7. Oxygen, the atomic number is 8. Chlorine, 17. Potassium, 19, iron 26, and gold 79. So no other element can have the same atomic number. So this is very unique to the atom, and it defines the physical and the chemical properties, as well as the number of the electrons and the neutrons also. So, and in fact the mass number. Okay, so the mass number, again, it can vary a little bit depending upon the isotope, but what we are showing here is the rounded up average atomic mass of the isotopes. So isotopes, as you know, are the same number of protons, but different number of neutrons of an atom. So here you have the hydrogen. The atomic number is 1, the mass number is 1, the number of protons is 1. The number of protons and the number of electrons are going to match for neutral atoms. So it will be the same. And the number of neutrons is the mass number minus the number of protons, and that gives you the neutron. So that's the formula, okay, as you can see on the top here where the cursor is. All right, so look at this nitrogen. Nitrogen, the atomic number is 7. So number is 7, atomic number. That means the number of protons is 7, and the number of electrons is also 7. You see that? Now comes the number of neutrons. So you take the mass number minus the number of protons or the atomic number. So 14 minus 7 is 7. So the number of neutrons comes out to be 7. Okay, now look at the other one. The oxygen. Oxygen, 8, atomic number 8. This means that the number of protons is 8. So you see here, number of protons 8, and as many number of protons as there are electrons in the neutral atom. That's why it becomes neutral. So the number of electrons is 8. Now comes the mass number. The mass number is 16. So 16 minus the number of protons or the atomic number 8 gives you 8. So that is the number of neutrons. Let's look something different. Look at iron. Iron, the atomic number is 26. Very unique. 26, only 26 protons are going to make something that looks like iron, and you guys are familiar with that. Same thing with the gold. 79 protons are going to make an atom that you are familiar with, looks like gold, golden jewelry, for example. All right, so here you have the mass is 58 in the case of iron and 197 in the case of gold. Okay, now comes the scenario where you have where you have the number of protons. Number of protons in the atomic number is the same, 79 and 79. Electrons is also the same, 79 and 79. But the number of neutrons is the mass number minus the atomic number or the number of protons, same thing. So 197 minus 79 gives you 118. So 118 neutrons are there. Okay, same is the case with iron. 58 minus 26, and you get 32 protons, neutrons. Okay, so 32 neutrons. So this is how you calculate the number of neutrons in the atoms and identify the parts to it. Okay, so now we are going to look at, in this video, we are going to look at the problem number 27. Okay, so problem number 27 is on page 116 in this book. 116. Okay, so let's start. Let me bring this larger and here. So here you are being asked to write the names and the symbols of elements which have these atomic numbers. So for that, you're going to consult the periodic table. So when you look at the periodic table, you will see that the number 3, look at the atomic number 3. Look at the atomic number 9. Look at the atomic number 20. So let's do that. Okay, so now I have this periodic table opened up. So you see the numbers that are on the top are the atomic numbers. The number 1 is for hydrogen, 3 for lithium, 4 for beryllium, 5 for boron, 6 for carbon, 7 for nitrogen, 8 for oxygen, 9 for phosphorus, and 10 for neon, and then 11 for sodium, 12 for magnesium. So these also mean the number of protons. So these numbers, the number on the top is that of the number of protons also. This also means the number of electrons and the mass number. And the mass number is the big one. The big one at the top is the mass number. Now, this is the isotopic mass, okay? This is the isotopic mass. And isotopic mass is the average mass of all the isotopes. So that number we put here. But you can always round this up. So you will generally see sodium 23. Instead of 22.99, okay? Now, let's look at the problems from the book, and we will go from there. So we are looking at the problem 4.27, and we are looking at the atomic number 3. So atomic number 3 is for lithium. You see that? So they're saying identify that element that has the atomic number 3. So the name of that element is lithium, right? And the symbol is, name is lithium, and the symbol is Li. Next question B. What is the atomic number of the, like if the, which element is that with the atomic number 9? So 9 is that of fluorine. So Fluorine is the name, but F alone is the atomic number, okay? F alone is the symbol, sorry. Then comes the atomic number 20. So atomic number 20 is this, calcium, okay? So calcium, Calcium is calcium, and the symbol is Ca. Okay, so I'm doing only 3, but I want you to do the remaining on your own. Okay, now next comes the problems from 4.27, in which they are saying how many protons and electrons are in argon. So, you know, obviously, argon is here. Okay, argon. So argon is, let's just hover. Wait, what happened here? Okay, argon. So see on the left-hand side, argon. Argon is 18. So argon is 18, and write down the mass number also. So argon 18, and the mass number is 39.94. So it is okay for here, for now, to round it up and make it, instead of 39.94, make it 40. Okay, so commonly we use that, this type, like we can round it up. The next question, I'm just noting down from the periodic table, then I'm going to show you how to do these problems on the other slides. So how many protons and electrons are in manganese? Now you need to look for what does a manganese? Manganese is right here, manganese. So this exercise is going to help you look at the periodic table. So manganese is Mn, the symbol is Mn, and you see the atomic number is 25, and the mass number is 54.938. So you can round this up and make it 55. Now, you can round up, but don't round down. So for example, if you have a number like nitrogen, so nitrogen is 14.007, so you will only use 14, okay? Now, oxygen is 15.99, you can make it 16, okay? Fluorine is 18.99, you can make it 19, all right? But neon is 20.180, so just leave it at 20, okay? For example, you have another one is like zinc, 65.38, just use 65. For example, you have, which is the other one, like so magnesium. So magnesium is 24.305. So just use 24. So you only round up, for example, in the case of sodium, if the number is 9, I mean above 5. So 22.99 becomes 23. Similarly, nickel, 58.693 becomes 59, right? Iron is 55.84. Commonly we use it as 56. So mass numbers you can round up, but if after decimal the number is above 5, but if it is below 5, you just use the number as is. Okay. Now, so that was for the that was from the periodic table. All right, let's go back and show you how to do the problem. So just wait for a minute. Okay, so you see, we already covered 4.27 when I showed you the periodic table. So we had the atomic numbers, and then, the rest of the questions you're going to look on your own, the way I showed you in the periodic table. So, that's going to give you a little exercise also in looking at the elements also, and kind of afterwards. So if you keep looking at the periodic table afterwards, you get an idea of what is present where. Besides that, as I told you earlier, I showed you in my previous videos about the mnemonics, remembering the the names, symbols, and the placement in the periodic table, the groups, the group numbers, right? All those things. So keep working at it. Okay. I do have a memorization quiz in which you will be, assessing how much you are able to remember. But anyways, let's do this now. Now, here comes this question, the next one, where argon is given to you, and you are being asked to find the number of protons and the electrons. So always remember, the small number is the atomic number. So this is the atomic number, and atomic number corresponds to the number of protons, and this corresponds to the number of electrons. Okay, this is the mass number, and the mass number is basically the atomic the number of protons plus the neutrons. So if you were to find the number of neutrons, you are going to take the mass number and you are going to subtract the atomic number, or you can also subtract the number of protons. Okay, so this is our formulas. And here we see that if they ask you what is the atomic number, let me do this in a different pen. Here, atomic number is 18. Number of protons is 18. Number of electrons is 18. So all these numbers are the same. Okay, the mass number minus, so in other words, 40 minus 18, and that is going to be the number of neutrons. Okay, so let's get that one. 14 minus 18. What do you get? 40, not 14, I'm sorry. 40 minus 18, and that is 22. Okay, so 22. So the number of neutrons is 22. So in this question, even though they didn't ask, but I still did it. Okay, anyways, next is they're saying how many protons and electrons in the next one. So same thing, the number of protons is equal to 25, and the same number is the electrons also for neutral atoms. Okay, if there is a charge, then this number of electrons change. All right, so the number of electrons is also 25. Okay, and the rest of it you are going to do on your own. So that'll give you a practice. Otherwise, it's just me doing the work. Okay, so you do these on your own. Okay, next question is about the isotopes. How do we calculate the these isotopes are given, and the same thing here. So in this case, let's do in a different color. Okay, number of protons. Now remember, the big number is the mass number. Okay, this is the mass number, and the small number is the atomic number. Okay, so number of protons, 38. Number of electrons, 38. And number of neutrons is 89 minus 38. So what do you get here? 89 minus 38, and you have 51. Okay, so there are 51 neutrons. Okay, next here, same thing, number of protons for chromium. Number of protons in chromium is 24. Number of electrons is 24. Okay, so the protons and the electrons is the same. But the number of neutrons is 52 minus 24. And in this case, you have 52 minus 24, and you have 28. Okay, so the number of neutrons is 28. All right. Now, the rest of it, the rest of the problems, you should be doing on your own. Okay. So next is write the atomic symbol if you are given the characteristic. Now here, so again, you're going to be using the periodic table. So let's do this. Let me open the periodic table and okay, so we are now looking at 15 protons and 16 neutrons. So remember that in the periodic table, this information is about the protons. All right, all these are the protons and atoms with the protons, but no neutrons are there. Obviously, you have to subtract the mass number and the atomic number. So then in that case, then you can get the neutrons. So, but all this information is about the protons. So the question is 15 protons. Which element has 15 protons? 15, the atomic number, and that is phosphorus. Okay, so the mass number, note down the mass number, 30.974, and we can round up to make it 31. Let's do this. So this is proton, this is phosphorus, and phosphorus P, and now 16 neutrons. So the mass number, so it's 15, and the mass number is 30.974, and you can round it up to 31. So commonly we use 31. Now 31 is the mass number. Okay, now 31 is the mass number and minus the number of protons, 15. Okay, so then this becomes what? Or in other words, you can use that, or you can also do it the other way around, that 15 protons, right? Plus they've given you neutrons here, which is 16 neutrons. So this becomes 15 plus 16 is 15. 15 plus 16 is equal to 31. And that is the mass number. Okay, so you can also write this here. So this relates, this is what it means. So this thing is what we see in the periodic table. Okay, all right. Next is 50 electrons and 72 neutrons. So we are not going to look at the neutrons from the periodic table. Now you know that this number of protons for a neutral atom is equal to the number of electrons. So if we are given 50 electrons, this translates as 50 protons. That means now you are going to look in the periodic table and we will see which one has 50 protons. So we see here tin, SN, tin. Okay, 50. So that is the number of protons, and that is also the number of electrons. So 50 and 118.71. So let's go here. So tin, oh, sorry, I was here. Tin, 50. And 72 neutrons means 50 plus 72. And this gives you 2 and 122. Remember, for isotopes, this is an isotopes. The actual weight, it's not going to, remember that the actual weight of tin, 118.71, is the average isotopic mass. That's the average of the mass of all the isotopes is 118.71. But this guy we get here, which is 50 plus 72, and that comes out to be 50 plus 72 comes out to be 122. So it's a heavier isotope. Regardless, sorry, if there is 50 protons or 50, then definitely it is tin and nothing else. Okay, the only difference is it's a heavier isotope, And it's a heavier isotope means that atom which has a different number of neutrons, a heavier number, like, the neutrons are different. Okay, next question is, they have given you chlorine with the 18 neutrons. Now they have already given you the identity of the element, chlorine, right? So write down chlorine. Let's go back and check. So where is chlorine? Chlorine is here. Chlorine 17, 35.45. So commonly we just use 35. Okay. Now chlorine 17. So chlorine is always 17. And they're saying write down that atom of chlorine which has 18 neutrons. So 17 plus 18 neutrons. Remember, at the bottom we have to write the mass number. So 17 plus 18 is 17 plus 18 is equal to 35. Okay, so 35. So this is what I did. So that's the mass number. Remember, we got the atomic number from the periodic table. Okay. So, and why we took 17? Because we are already given the identity, the chlorine, the identity of the atom is already given. That's how we looked at that in the periodic table. Okay. So the rest of it you are going to do on your own. There are like few more questions you do on your own. Okay, for practice. All right. Next is calculate the atomic mass of gallium isotopes. Okay. So here, what are we doing? Here we are given gallium 6931, gallium 7131. Okay. Now they have given you the abundance, which is the natural and nature. How much of gallium 69 is there? 60.11. And how much of gallium 71 is present? It's 39.89. Remember, the atomic number is the same. Now, it doesn't matter where you write the atomic number. You can write on the top or you can write on the bottom. It really doesn't matter. The main thing is that what are we doing with these numbers? So in this case, we are looking at the mass number. We are calculating the mass number. So we have put this on the top, the average isotopic mass. Okay. So this is the method. This method is called the average isotopic mass. Okay. Now, all you need to do is you are going to, and you are also given the 68.93 atomic mass units. This is already given to you. All right. So what will you do next? You are going to take 60.11, divide that by 100. That's what it means, right? And the other one is 39.89, and then you divide that by 100. Okay. The next thing, you're going to multiply it by the mass. And let's see what numbers we get. Now, here's also another thing, using the significant figures. So we have here, let's get this. Okay, here you have 60.11, or rather, let's put it on this one, 60.11, 4 significant figures, 4 significant figures, 4 significant figures, right? And 39.89, this is also, let me just double check this. Anyway, so this is 4 significant figures. Okay, just hold on, let me double check. Okay, so it was 70.92. Okay, so that atomic mass unit. Okay, anyway, so now you multiply 60.11 times 68.93 divide by 100. And similarly, 39.89 times 70.92 divide by 100. Okay, so when you finish the calculations, you get the 41.43 in the first one and 28.28 in the second one. Now, here's the thing. First, 4 significant figures that we got. So this is 4 significant figures, 4 significant figures, 4 significant figures, 4 significant figures. Okay, so we are also going to keep it as 4 significant figures, 4 significant figures. Now, another rule is that when you add, now this you are going to add, okay, add these. So when we add these, okay, we are going to look at the 2 decimal places. So this is 2 decimal place, and this is 2 decimal place. So your final answer should also have 2 decimal places. Okay, so now let's do this. So we have so we have 28.28 plus 41.43, and you get 69.71. And all the, if you have extra numbers after that, you just drop them. So 69.71. So that is the average. The average isotopic mass is, so I already have this written. The average mass that you put for all the isotopes is this number that you see in the periodic table. So gallium is 69.71. That is why commonly we use it as 70, right? All right, let's see, 69.71 gallium. Where was gallium? 1 second. Gallium 31. See right here, gallium. So, I worked with, they have given you 3 places after the decimal, which is fine. Some periodic tables you would see 69.723. Some places you will see 69.72. Some places you will see 70 also. That's fine. But this is like a little bit more exact, just a little. So remember the accuracy, precision, those things. So anyway, so that finishes this section. And then we are going to continue with the energy levels in the next video. All right. Okay. Thank you for watching. Bye-bye.